Look up at the night sky, really look, and tell me what you see. A random scattering of stars. A cold, empty void. Or something far more extraordinary. What if I told you that every galaxy, every swirling nebula, every flickering star is part of something far grander, not just a universe governed by rigid laws, but a living, breathing masterpiece, evolving across billions of years like the strokes of some celestial artist's brush? This is the idea we're exploring today, that the cosmos might be the greatest work of art ever created, a perfect blend of science and beauty, where the equations of physics compose symphonies of light and matter. Think about the last time you stood in awe before a painting, the way colors blend, the emotions stirred by a single image. Now imagine that same feeling, but on a scale so vast it defies comprehension. The birth of a star isn't just a nuclear reaction, it's a fiery burst of creativity. The spiral arms of a galaxy aren't just gravity's handiwork, they're cosmic calligraphy written in stardust. Even the way planets orbit their suns mirrors the perfect harmony of a dance, each movement precise yet filled with grace. Science gives us the rules, but art gives them meaning. So let's take a journey not just through space, but through the very idea of creation itself. We'll unravel how the universe's most fundamental forces weave together in ways that feel almost intentional, as if every quark and every supernova were part of some grand design. By the end, you might never look at the night sky the same way again, because if the universe is an evolving masterpiece, then we're not just observers, we're part of the canvas. And that changes everything. Take a moment to picture the swirling colors of the Orion Nebula, its vibrant blues and pinks stretching across light years like a cosmic watercolor. That's no accident. The same forces that mix pigments on a painter's palette, blending, diffusing, layering, are at work in those interstellar clouds where gravity and radiation sculpt gas into ethereal shapes. Or consider the Whirlpool galaxy, its arms spiraling with mathematical precision, yet pulsing with the raw energy of billions of stars. It's a structure so flawless, it could have been sketched by a Renaissance master studying the golden ratio. Even chaos has its artistry. Look at a black hole's event horizon, where light bends into impossible curves, warping reality like a Dali painting. The universe doesn't just follow rules, it plays with them, turning physics into poetry. And just as artists experiment with textures and contrasts, cosmic forces balance order and turbulence. Supernovas explode in violent bursts, yet their remnants seed new stars, echoing the cycle of destruction and rebirth found in every great work of art. What's truly remarkable is how humans, tiny specks on a pale blue dot, recognize this beauty instinctively. A scientist analyzing a galaxy's rotation curves and a painter capturing its likeness on canvas are, in a way, speaking the same language. One uses equations, the other brushstrokes, but both are chasing the same truth, that the universe doesn't just exist, it expresses. From the fractal branching of lightning to the rhythmic pulse of colliding neutron stars, nature's creativity hums in every wavelength, inviting us to see science not just as calculation, but as revelation. Fractals are nature's signature, a hidden language of repetition and scale that whispers through everything from the branching veins of a leaf to the vast, winding rivers of galaxy clusters. Zoom in on a snowflake, and you'll see the same intricate patterns repeating infinitely, as if the universe pressed copy and paste on perfection. Artists have been channeling this cosmic rhythm for centuries, even before they understood it. Jackson Pollock's chaotic drips and splatters, they weren't just random scientists analyzing his work, found fractal dimensions matching those in turbulent fluids and star-forming regions. It's as if his brush tapped into the same mathematical pulse that shapes nebulae, But here's the breathtaking part: fractals aren't just pretty patterns. They're the universe's way of optimizing space, energy, and growth. A tree's branches split to reach sunlight efficiently, just as cosmic webs of galaxies stretch along fractal filaments to weave the large-scale structure of reality. Mathematicians study them to decode the rules of complexity, while painters like Hokusai captured their essence in the curling waves of the Great Wave off Kanagawa, each crest a miniature echo of the whole. Science quantifies these patterns, art makes us feel them. This duality reveals something profound. The universe doesn't distinguish between disciplines. A physicist calculating fractal dimensions and an artist sketching a fern's fronds are both tracing the same invisible blueprint, one with numbers, the other with intuition. Even our bodies follow fractal logic, the branching airways in our lungs, the neural pathways in our brains. It's as if we're built from the same cosmic recipe, a reminder that art and science are just two dialects of a deeper, universal language. The next time you see a spiral seashell or a thunderhead swirling clouds, pause. You're not just looking at nature, you're glimpsing the artistry woven into the fabric of existence itself. Gravity pulls the strings of the cosmos like a master cellist, drawing galaxies into sweeping arcs across the void. Electromagnetism plucks at atoms like harp strings, setting electrons into rhythmic orbits. And quantum mechanics, that's the percussion section, unpredictable, staccato, filling the silence between stars with a chaotic energy that somehow resolves into perfect order. Together, these fundamental forces don't just govern the universe, they perform it. Every collision of neutron stars, every magnetic dance of auroras, every quark's sudden leap is a note in a symphony written in the language of physics. Think of Gustav Holst's The Planets, where each movement mirrors a celestial body's character, Mars with its warlike drums, Venus with its serene strings. Or Vangelis' Cosmos, where synthesizers hum with the same otherworldly resonance as solar winds. These composers didn't just imagine the music of the spheres, they listened to the equations. When a star collapses into a black hole, space-time vibrates like a struck gong, emitting gravitational waves we can now detect as sound. Translate those ripples into audible frequencies, and you'll hear a rising chirp, a cosmic crescendo. Even the silence speaks. The vast voids between galaxies aren't empty. They're the rests between measures, giving structure to the composition. And just as a symphony builds tension before resolution, the universe balances forces in delicate opposition. Gravity tugs matter inward while dark energy pushes it apart, creating a dynamic equilibrium that keeps the cosmic score from collapsing into noise. What's most astonishing is how human ears evolved to hear rustling leaves and rushing rivers can still sense this grand harmony. When astronomers convert radio emissions from Saturn's rings into sound, the result is eerie choral music, as if the planet were singing. The same mathematical ratios that make a Bach fugue pleasing, the golden ratio, harmonic intervals, underpin the orbital resonances of moons and planets. Science unveils the sheet music, art lets us hear the melody. So next time you gaze at the stars, remember, you're not just looking at the universe, you're listening to it. Light defies simple explanation. It's both a particle and a wave, a paradox that dances on the edge of understanding. Scientists grapple with its quantum quirks, while artists chase its fleeting beauty, yet both are captivated by the same phenomenon. Isaac Newton's prism experiments revealed light's hidden spectrum, splitting sunlight into ribbons of color like an unseen painter's palette. Centuries later, Claude Monet stood in fields at dawn, capturing the way light fractured into hues the human eye could barely name. Science dissects light into wavelengths and photons. Art worships its glow on water, its shadow play on skin. But these aren't opposing pursuits, they're two hands sculpting the same truth. Consider a rainbow. To a physicist, it's refraction and dispersion, water droplets bending light into a predictable arc. To a poet, it's a bridge between worlds, a fleeting miracle. Yet both responses stem from awe at light's ability to transform. Even the tools we use to study it mirror artistic mediums. A spectroscope breaks starlight into chemical fingerprints, much like stained glass filters sunlight into sacred patterns. The Hubble telescope's images of distant nebulae aren't just data, they're cosmic frescoes painted by photons that traveled millennia to reach us. Light's duality extends beyond physics. In Vermeer's Girl with a Pearl Earring, a single reflected highlight brings the canvas to life, proving that illumination isn't just about visibility, it's about meaning. Similarly, the double-slit experiment shows light as both wave and particle, its behavior shifting based on how we observe it. Art and science both ask, does reality exist before we perceive it? A sunset's reds deepen because the atmosphere scatters blue light, a scientific fact that only heightens its emotional power. This interplay reaches its peak in technologies born from light's mysteries. Lasers, born from Einstein's equations, now sculpt marble and correct vision. OLED screens, descendants of quantum research, glow with colors once reserved for stained glass. Even the humble camera lens owes its existence to both optics and aesthetics, bending light to freeze moments in time. The universe speaks in photons, and whether we're measuring their energy or marveling at their radiance, we're hearing the same cosmic whisper. Light doesn't choose between science and art. It is both a beam of knowledge and a brushstroke of wonder. Time doesn't just pass, it sculpts. Like an artist's hands shaping clay, it presses its fingers into the fabric of reality, leaving behind galaxies as fingerprints and mountains as brushstrokes. Salvador Dali's melting clocks captured time's fluidity, but Einstein revealed its true nature, not a rigid metronome, but a pliable river, bending around stars and stretching near black holes. Both the artist and the physicist understood something profound. Time isn't just a measurement. It's the universe's chisel, carving canyons into rock and wrinkles into skin, while simultaneously weaving the delicate patterns of a butterfly's wings or the spiral arms of the Milky Way. Consider the Grand Canyon, its layers exposed like pages in a geologic novel. Each stratum tells a story, not just of erosion, but of patience. Time sculpted those cliffs grain by grain, just as Michelangelo freed David from marble, chip by chip. Or take the rings of Saturn, those luminous disks that seem frozen in perfection. They're not static. They're the result of countless collisions and gravitational dances, a celestial ballet choreographed over billions of years. Destruction and creation are time's twin tools. Supernovas obliterate stars, yet their ashes birth new solar systems. Ice ages scour continents, only to make way for lush forests. Even the atoms in your body were forged in ancient stellar furnaces, proof that time doesn't erase, it recycles. Artists have always wrestled with this duality. The Japanese practice of kintsugi repairs broken pottery with gold, celebrating cracks as part of an object's history. Similarly, the universe's scars, cratered moons, fractured tectonic plates aren't flaws. They're part of the masterpiece. Physicists see time's arrow in entropy, the inevitable drift toward disorder. But entropy isn't just decay. It's the reason heat flows, engines run, and life metabolizes. Without it, the cosmos would be a frozen statue, beautiful but lifeless. The most striking parallel lies in evolution. Time doesn't hurry as it sculpts life forms, favoring the subtle mutation that grants a finch a stronger beak or a moth darker wings. It's a slow, iterative artistry, nature's version of a painter layering glaze upon glaze until the image emerges. and just as artists revise their work, time edits. Dinosaurs dominated for millions of years, only to vanish in a fiery instant, making room for mammals to rise. It's brutal, yes, but also breathtakingly creative. Perhaps that's why we're so captivated by time-lapse videos, whether it's a blooming flower or a swirling galaxy. They let us witness the invisible hand of time at work. In those sped-up moments, we catch a glimpse of the universe's true rhythm, not seconds or hours, but the patient, relentless pulse of transformation. Time doesn't just move forward, it sculpts, destroys, and recreates an eternal artist with an infinite canvas. Chaos isn't the opposite of order, it's order waiting to be understood. Watch a drop of ink swirl through water, its tendrils stretching and folding in unpredictable patterns, yet beneath that apparent randomness lies a hidden rhythm. Scientists call it turbulence, a phenomenon so complex that even the brightest minds struggle to model it perfectly. Yet, in that chaos, there's a strange beauty, a dance of forces that mirrors the way Van Gogh's starry night whirls with frenetic energy, each brushstroke a calculated rebellion against the blank canvas. The universe doesn't shy away from disorder, it harnesses it, from the violent storms on Jupiter to the delicate veins of a lightning bolt. Chaos becomes a tool for creation. Take weather systems. A butterfly flapping its wings in Brazil might set off a chain reaction leading to a tornado in Texas, the famous butterfly effect. Meteorologists map these chaotic interactions with supercomputers, yet the outcome remains tantalizingly unpredictable. Now, look at Jackson Pollock's drip paintings. His method wasn't random. It was a controlled chaos, with every flick of the wrist obeying the same fluid dynamics that govern rivers and galaxies. Scientists analyzing his work found fractal patterns identical to those in turbulent flows, proof that art and nature share the same messy, magnificent blueprint. Even the birth of stars thrives on chaos. A nebula might seem like a serene cloud, but inside, it's a battlefield of gravity, pressure, and magnetic fields. Gas collapses into knots, spinning into protostars while shockwaves rip through the dust. It's messy, violent, and yet, from that turmoil emerges the precise nuclear fusion that lights up suns. Abstract artists like Wassily Kandinsky understood this duality. His compositions burst with seemingly chaotic shapes and colors, yet they're built on geometric principles, much like how a supernova's explosion follows the rigid laws of physics even as it scatters stardust across the void. Chaos theory reveals something profound. What looks like disorder is often just complexity we haven't decoded yet. The Mandelbrot set, a fractal infinite in its intricacy, emerges from a simple equation iterated over and over. Similarly, a jazz improvisation might sound spontaneous, but it's rooted in scales and rhythms rules that set the stage for creativity. The universe works the same way. Quantum fluctuations, the jitter of particles at the smallest scales, seem random, yet they seed the large-scale structure of the cosmos. Without that microscopic chaos, galaxies wouldn't form. This interplay between chaos and order isn't just science or art, it's a fundamental truth about existence. A forest fire destroys, but it clears the way for new growth. A composer introduces dissonance to make the resolution sweeter. Even our brains rely on chaotic neural firing to generate creative thought. Disorder isn't the enemy of beauty, it's the raw material. So the next time you see a storm cloud or a splash of paint, remember, you're witnessing the universe's way of turning chaos into something breathtaking. It's not a flaw in the masterpiece. It's the brushstroke that makes it real. The Big Bang didn't just happen, it erupted onto the cosmic stage with the raw energy of a sculptor's first strike against marble. Picture this, an unfathomably dense point, smaller than an atom, suddenly unfurling into the vast expanse of space-time. But this wasn't mere expansion. It was the universe's first creative act, a burst of pure potential where every law of physics, every particle, every force emerged like colors mixing on a palette. Scientists trace echoes of that moment in the cosmic microwave background, those faint ripples of heat that paint the sky like the ghostly underpainting of a Renaissance fresco. What they're seeing isn't just radiation, it's the universe's rough sketch, the primal strokes that would later shape galaxies. Think of the most vibrant explosion in art, maybe Turner's fiery sunsets or Yayoi Kusama's infinite polka dots, and then imagine that energy multiplied by trillions. Within fractions of a second, quarks danced into protons, photons blinked into existence, and the very fabric of reality stretched like wet canvas. This wasn't chaos, it was creativity in its purest form. Like Jackson Pollock flinging paint to create order from splatters, the Big Bang set in motion patterns that would later crystallize into superclusters and solar systems. Even the asymmetry of matter and antimatter, why we exist at all, feels less like an accident and more like an artist's intentional imbalance, the way a composer might silence one instrument to let another shine. The parallels go deeper. Just as artists work with constraints, canvas size, pigment chemistry, the Big Bang followed precise rules. Gravity sculpted, electromagnetism colored, and the strong nuclear force bound everything together like invisible brushstrokes. But here's the wonder, within those constraints, infinite variation emerged. The same quantum fluctuations that seeded galaxy formation also mirror the happy accidents in watercolor, the way pigments bloom unpredictably, yet create breathtaking depth. Even the universe's imperfections, those slight variations in density, become part of the masterpiece, like the purposeful cracks in a Roku pottery glaze. What's truly humbling is how this creative pulse still resonates. Every atom in your body was forged in those first explosive minutes, meaning you're not just observing the artwork, you're part of its composition. The iron in your blood came from dying stars, the calcium in your bones from colliding nebulae. Your stardust, yes, but also something more, a living brushstroke in a canvas that's still expanding. The Big Bang wasn't a one-time event. It's an ongoing performance, with each supernova, each spinning planet, each beating heart adding to the composition. Science measures the how, art reveals the why. Together, they show us that creation isn't just a moment, it's the universe's deepest instinct. Dark matter is the universe's ghostly architect, weaving an invisible framework that gives shape to everything we see. Imagine a cathedral held up not by stone pillars, but by the empty spaces between them, where the absence of material somehow creates strength. That's dark matter. It doesn't glow, absorb, or reflect light, yet without its gravitational pull, galaxies would spin apart like paint flung from a palette. Scientists estimate it makes up over 80% of the universe's mass, a hidden scaffold stretching across the cosmos, its presence felt only by the way it bends the paths of stars and warps the fabric of spacetime itself. This unseen force mirrors one of art's oldest principles, negative space. Take a Japanese ink painting where the blank paper isn't just a backdrop, it's an active part of the composition, shaping the viewer's perception of the inked lines. Or consider Michelangelo's David, where the empty space around the statue amplifies its grandeur. Dark matter works the same way. Its gravitational embrace molds galaxies into spirals and clusters into vast cosmic webs, yet it remains as elusive as the unmarked portions of a canvas. The beauty lies in what isn't there, the way emptiness defines form. Even our tools for detecting dark matter feel artistic. Astronomers map its presence indirectly, like sculptors working blindfolded, tracing contours by touch. They watch stars orbiting too fast at the edges of galaxies, or light bending around invisible mass, clues as subtle as the faint pencil lines beneath a fresco. Some experiments hunt for dark matter particles deep underground, shielded from cosmic noise, much like restorers scrutinizing a masterpiece under ultraviolet light to find the artist's hidden fingerprints. But here's the poetic twist. Dark matter might not just shape the universe, it could be the reason we're here to admire it. Without its gravitational glue, the early universe's matter would have scattered too thinly for stars and planets to form. No dark matter, no Earth, no Michelangelo, no telescopes. It's the ultimate example of creation relying on the unseen, a reminder that the most profound forces often leave no visible trace. Artists have always grappled with the power of absence, the haunting gaps in Rachel Whiteread's cast sculptures, the silent pauses in a Beethoven symphony, the uncharted margins of ancient maps all speak to the human instinct to find meaning in the invisible. Dark matter invites us to do the same on a cosmic scale. It's not a void, it's the scaffolding of reality, the silent partner in the universe's grand design. And just as negative space makes art breathe, dark matter makes the cosmos dance. Black holes don't just bend space-time, they rewrite it, twisting the fabric of reality into shapes that would make even the boldest sculptor pause. Imagine dipping a brush into thick, swirling ink and dragging it across wet paper, the way the pigment bleeds outward, distorting the surface beneath it. That's what a black hole does to the universe. Its gravitational pull is so fierce that near its event horizon, time slows to a crawl, light stretches into crimson smears, and space itself folds like origami. Scientists call this spaghettification, a playful term for a terrifying truth. Get too close, and you'd be stretched into a thread of atoms, your very being unraveled into the cosmic unknown. Yet there's a strange beauty in this violence. Black holes are the ultimate paradox, regions of infinite density surrounded by swirling disks of superheated gas that glow like halos. The first image of a black hole's shadow, captured by the Event Horizon Telescope, revealed a fiery ring of light warped into a perfect circle, a cosmic tondo framed by gravity's grip. It's no accident that the photo resembled the Eye of Sauron or the radiant mandalas of Buddhist art. Black holes tap into something primal in us, a mix of awe and dread that artists and philosophers have chased for centuries. The Romantic painters called it the sublime, the thrilling terror of facing something vast and incomprehensible. Standing before Turner's storm-tossed seascapes or Caspar David Friedrich's fog-shrouded cliffs, you feel the same vertigo as when pondering a singularity, the dizzying pull of the infinite. What's even more astonishing is how black holes create. Their tidal forces don't just destroy, they sculpt. Jets of plasma shoot from their poles at near light speed, carving channels through galaxies like cosmic blowtorches. These jets can trigger star formation, seeding new suns in their wake, destruction birthing creation, much like how a forest fire clears the way for fresh growth. Even the gravitational waves they emit when colliding ripples in spacetime detectable billions of light years away are a form of art. Translate those waves into sound, and you'll hear a rising chirp, a fleeting duet between two collapsing giants. Perhaps the most poetic twist is how black holes mirror the creative process itself. Inside the event horizon, all known laws of physics break down. It's a blank canvas where reality as we know it ceases to exist, a place of pure potential, like the white page before a poet's first word. Theorists like Stephen Hawking suggested that information swallowed by a black hole isn't truly lost. It's scrambled, remixed, perhaps even projected back into the universe in some holographic form. In other words, black holes might be the ultimate recyclers, turning stardust into something new. That's why they captivate scientists and artists alike. To a physicist, they're laboratories for testing relativity and quantum mechanics. To a painter, they're the deepest blacks imaginable, voids that suck in light yet somehow radiate meaning. And to all of us, they're reminders that the universe's most terrifying forces are also its most creative. A black hole isn't just a cosmic vacuum cleaner. It's a brushstroke, bold, dramatic, and essential to the masterpiece. A supernova is the universe's grand finale, a star's last, defiant act of self-destruction that lights up the cosmos brighter than an entire galaxy. But here's the paradox: in that apocalyptic blast, scattered across the void like cosmic confetti, lies the raw material for everything we know. The iron in your blood, the calcium in your bones, even the oxygen filling your lungs. All of it was forged in the heart of a dying star and hurled into space by the very explosion that ended its life. Supernovas aren't just deaths, they're rebirths in disguise, scattering stardust like seeds for new worlds. Think of it like a phoenix, but on a scale so vast it defies imagination. When a massive star collapses, its core implodes with such force that the shockwave rips through its outer layers, flinging them outward at millions of miles per hour. For a few weeks, that single star outshines its entire host galaxy, a fleeting masterpiece of light and energy. Artists have tried to capture that brilliance for centuries. The swirling gold leaf in Gustav Klimt's The Kiss mirrors the luminous chaos of a supernova's aftermath, while the explosive brushstrokes of abstract expressionists like Joan Mitchell echo the raw, unfiltered power of stellar death. But the real magic happens after the light fades. Those scattered elements, carbon, nitrogen, gold, drift through space, drawn together by gravity's invisible hand. Over eons, they clump into molecular clouds, then protoplanetary disks, and finally, new solar systems. Our own sun and planets are the children of such an explosion, recycled stardust given form. It's nature's ultimate act of creative destruction, where the end of one story becomes the prologue to countless others. This cycle mirrors artistic reinvention. Just as a supernova's debris fuels new stars, old ideas in art and science don't vanish, they transform. Picasso's blue period gave way to cubism, just as Newton's physics paved the way for Einstein's relativity. Even in literature, the ashes of outdated narratives feed fresh storytelling. The Norse myths of Ragnarök, where the world ends only to begin anew, or the Japanese concept of wabi-sabi, finding beauty in impermanence, all echo this universal truth: destruction isn't the opposite of creation. It's its partner. Supernovas teach us something profound about resilience. The same forces that obliterate also nourish. A forest fire clears the way for new growth. A sculptor chips away stone to reveal a statue, and a star's catastrophic end becomes the reason planets and life can exist at all. The universe doesn't waste a single atom. It recycles, reimagines, and rebuilds. So the next time you feel like something in your life is ending, remember the supernova. What looks like a finale might just be the universe whispering, wait for the next act. Earth hangs in a cosmic sweet spot, not too close to the sun's furnace, not too far in the freezing dark, but just right for oceans to ripple and forests to breathe. Scientists call this the Goldilocks zone, where liquid water can pool and molecules can dance into life. But step back and you'll see something astonishing. This isn't just a happy accident of physics. It's a masterclass in balance, a celestial tightrope walk where gravity, chemistry, and light conspire to create conditions so precise they feel almost intentional. Think of a painter mixing pigments to capture the exact shade of a sunset, a dab more red, a touch less blue, until the hue vibrates with perfect harmony. The universe does the same with planets. Venus, our neighbor, is a broiling hellscape choked in greenhouse gases. Mars, a step farther out, is a frozen desert. But Earth is the canvas where sunlight, atmosphere, and water blend in proportions so delicate, even a slight tilt in our orbit could tip the scales toward sterility. The Goldilocks zone isn't just about distance. It's about the interplay of countless variables, each fine-tuned like instruments in an orchestra. Consider the sun itself, not too massive to burn out in a cosmic blink, not so small that its warmth barely reaches us. Its steady glow has nurtured life for billions of years, much like the even light of a studio lamp allows an artist to work for hours without shadows distorting their vision. And Earth's atmosphere, that's the universe's own filter, stripping away lethal radiation while letting through just enough energy to power photosynthesis. It's as if the planet wrapped itself in a breathable stained glass window, each pane calibrated to shield and sustain. Even Earth's rotation plays its part. The 24-hour day isn't random. It's a rhythm that balances heating and cooling, preventing scorching days and glacial nights. Compare that to Mercury, where one side bakes endlessly while the other freezes in perpetual darkness. Our planet spins like a potter's wheel, smoothing extremes into a livable gradient. And then there's the Moon, that silent partner whose gravity stabilizes Earth's tilt, keeping our seasons gentle and predictable. Without it, our axis might wobble chaotically, turning climates into roller coasters. What's truly humbling is how rare this equilibrium is. For every planet nestled in a Goldilocks zone, there are countless others too hostile for even the hardiest microbes. Yet here we are, on a world where rain carves canyons, where bees navigate by polarized light, where the air itself hums with the chemistry of life. Science explains the mechanics, but art captures the wonder. The way a Georgia O'Keeffe flower magnifies delicate detail, or a Hiroshi Sugimoto seascape frames the eternal dialogue between land and water. This balance isn't static. It's a dynamic dance, one that's shifted over eons. Ice ages have come and gone. Oxygen levels have soared and plummeted. Like a sculptor revising their work, the universe adjusts. Asteroid impacts reset the clock. Volcanic eruptions alter the atmosphere. And somehow, through it all, Earth systems self-correct, maintaining that precious equilibrium. It's a reminder that harmony isn't about perfection. It's about resilience, the same way a jazz musician bends notes to create something richer than rigid sheet music could ever dictate. So when you step outside and feel the sun's warmth or watch clouds drift across the sky, remember, you're not just standing on a planet. You're standing in a masterpiece, one where every variable, from the salinity of the oceans to the nitrogen in the air, has been tweaked to an almost impossible precision. The Goldilocks zone isn't just a scientific concept. It's the universe's signature on its greatest work, a living, breathing world suspended in the perfect balance between fire and ice. Quantum entanglement is like the universe's secret handshake, a hidden language where particles, no matter how far apart, remain mysteriously linked. Picture two electrons born from the same event, separated by the width of a galaxy. Change the spin of one and its partner instantly responds, as if they're whispering across the void faster than light should allow. Einstein called it spooky action at a distance, but this isn't just physics being weird. It's proof that the cosmos operates on connections deeper than space and time, threads woven into reality itself. Now shift your gaze to art. A cave painting in France echoes the same symbols found in Aboriginal Dreamtime stories, though the creators never met. A Renaissance masterpiece inspires a modern digital artist centuries later. These aren't coincidences, they're cultural entanglement, where ideas resonate across generations and continents, untethered by physical distance. Just as entangled particles defy classical physics, art transcends its origins, creating invisible bridges between minds separated by eras and oceans. What's truly mind-bending is how both phenomena rely on relationships rather than proximity. A photon hurtling through space doesn't care if its entangled twin is in another galaxy. Their bond is immutable. Similarly, Van Gogh's Starry Night doesn't lose its power when viewed in Tokyo instead of New York. The emotional impact transcends geography, just as quantum states transcend light years. Scientists measure entanglement with Bell tests. Artists measure it in the chills down your spine when a melody written 300 years ago feels achingly personal. This interplay reveals something profound about the universe's design. Whether through particles or pigments, reality seems to favor connection over isolation. The same quantum rules that entangle electrons might one day power unhackable communication networks, while the shared themes in art, love, loss, wonder, forge empathy between strangers. Both hint at a cosmos where separation is an illusion, and everything is part of a vast, whispering web. So next time you feel a pang of recognition staring at an ancient sculpture, or hear a song that feels written just for you, remember, you're not just observing art or science. You're touching the universe's hidden stitches, the places where it secretly ties everything together. String theory hums with possibility, a vision of reality where the tiniest building blocks of existence aren't dots or particles, but shimmering threads vibrating at different frequencies. Picture a guitar string, its pitch rising as you tighten the tension. Now imagine that same principle governing everything from the electrons orbiting an atom to the galaxies spinning in the void. According to string theorists, the universe isn't just governed by music. It is music, a grand symphony where each note corresponds to a quark, a photon, or even the fabric of space-time itself. This idea isn't just poetic, it's a potential bridge between science's greatest theories. Einstein spent his later years searching for a unified framework, a way to marry gravity with quantum mechanics. String theory whispers an answer. If all matter and energy arise from these vibrating strings, then the chaotic quantum world and the smooth curvature of relativity might be two verses of the same cosmic song. The math is fiendishly complex, but the metaphor sings. A violin's a note and a cello's a note are distinct, yet they share a fundamental frequency. Similarly, an electron and a photon might seem unrelated until you realize they're just different harmonics on the same tiny, thrumming string. Artists have intuited this harmony for centuries. The ancient Greeks tuned their lyres to the music of the spheres, believing planets hummed as they moved. Johann Kepler composed celestial melodies based on orbital geometries. Even Pythagoras, slicing strings to discover mathematical ratios, found that beauty and physics shared a common language. Fast forward to modern composers like John Cage, whose avant-garde works embraced chaos and order, much like string theory's dance of vibrating filaments in 11 dimensions. The parallels go deeper. Just as musical notes emerge from vibrations, the properties of particles, mass, charge, even their very existence might stem from how strings oscillate. A slight shift in frequency could turn an electron into a neutrino, the same way tightening a guitar string transforms a C into a C-sharp. And just as harmonies rely on precise intervals, the universe's constants, the speed of light, the strength of gravity, might be tuned by these underlying vibrations. Too sharp or too flat, and stars wouldn't ignite, atoms wouldn't bond. It's as if the cosmos is a finely crafted Stradivarius, its strings resonating in perfect balance. What's truly mesmerizing is how this mirrors human creativity. When a composer layers melodies into a fugue or a physicist weaves equations into a theory, Both are chasing patterns, connections hidden beneath the noise. String theory suggests those patterns aren't just human inventions, they're woven into reality's fabric. The same mathematical elegance that gives us Bach's counterpoint might govern quarks and black holes. Yet for all its beauty, string theory remains unproven. Critics call it a theory of maybe, lacking experimental proof, but isn't that the artist's struggle too? A painter envisions a canvas long before the first brushstroke. A composer hears a symphony in silence. String theorists, like avant-garde musicians, are working in the dark, guided by the hunch that somewhere beyond the limits of our instruments, the universe is singing. And if they're right, we're not just listeners, we're notes in the score, vibrations in an endless, unfolding opera. Multiverse theory stretches the canvas of reality beyond anything we've ever imagined. Not just one universe, but countless others, each with its own unique palette of physical laws. Some might be slight variations of our own, where gravity is a fraction stronger or light travels a touch slower. Others could be unrecognizable, where time loops like a Möbius strip or matter forms into geometries beyond human comprehension. It's as if the cosmos were an endless gallery, with every possible version of existence hanging side by side, each governed by its own brushstrokes of physics. Think of it like walking through an art museum where no two rooms share the same style. One universe might resemble a Monet, soft, blurred, where particles behave like watercolor drips blending into each other. Another could echo the sharp lines of a Mondrian, all rigid angles and primary forces, with matter snapping into place like grid lines. Some might even be pure abstraction, where causality unravels into splatters of chance, or surreal dreamscapes where black holes bloom like Dolly's melting clocks. The multiverse doesn't just suggest alternate realities, it proposes alternate rules, where creativity isn't confined to artists, but woven into the fabric of existence itself. Scientists grapple with this idea through frameworks like the inflationary multiverse or string theory's landscape, where tiny quantum fluctuations in the early universe sprouted separate bubbles of spacetime. Each bubble, isolated from the others, could have cooled into its own distinct physics. It's a dizzying thought. Somewhere, a universe might exist where the speed of light isn't a limit but a suggestion, or where atoms never learn to bond, leaving entire worlds as swirling clouds of loose particles. And just as artists experiment with techniques impressionism, cubism, pointillism, these universes might explore every possible permutation of reality, from the elegant to the bizarre. What's fascinating is how this mirrors the creative process. When a painter stares at a blank canvas, they face infinite choices, each brushstroke closing some doors while opening others. The multiverse is nature's version of that exploration, a cosmic what-if played out across eternity. Even the failures, universes where stars couldn't ignite or laws cancelled each other out, aren't wasted. They're part of the experiment, like an artist's discarded sketches that lead to a masterpiece. Artists have long flirted with this concept. Borges' garden of forking paths imagined a labyrinth of branching timelines. In Everything, Everywhere, All at Once, alternate lives collide in a kaleidoscope of chaos and meaning. These stories resonate because they tap into a deeper truth. Possibility is the lifeblood of both art and science. The multiverse simply takes that idea to its grandest scale, suggesting that every equation, every hypothesis, every stroke of genius or madness might exist somewhere in the cosmic archive. Yet for all its wonder, the multiverse remains a theory draped in mystery. Critics argue it's untestable, more philosophy than physics, but so were black holes once, or the idea that continents drift. Imagination has always been science's compass, pointing toward horizons before tools can map them. Whether the multiverse is proven or not, it expands our sense of what could be, just as art stretches perception, reminding us that reality is far stranger and more beautiful than it seems. So the next time you daydream about roads not taken, remember, in some universe those dreams aren't fantasies, they're reality. The multiverse isn't just a scientific hypothesis. It's the ultimate act of cosmic creativity, a reminder that every law of physics, every star, every life might be one variation in an infinite symphony of existence. And that makes our universe with its Goldilocks planets and entangled particles not just an accident, but a work of art, one of countless yet irreplaceable. Biological evolution operates like the world's most patient artist, sketching countless drafts before settling on a final piece. Every organism alive today is the result of billions of years of tweaks, revisions, and occasional happy accidents, a living testament to nature's relentless creativity. Take the human eye, for example. Far from a perfect design, it's a patchwork of adaptations, retinal wiring that creates a blind spot, light receptors clustered in ways that distort peripheral vision. Yet it works not because it's flawless, but because it's good enough, a work in progress refined over eons, much like a sculptor smoothing rough edges with each pass of their chisel. This process of trial and error isn't random. It's driven by constraints and opportunities, the same way an artist navigates the limits of their medium. A painter might layer glazes to achieve depth. Evolution layers mutations, selecting for traits that enhance survival. The branching patterns of trees, the spiral shells of mollusks, even the symmetry of a butterfly's wings, all follow mathematical rules that artists have borrowed for centuries. The Fibonacci sequence, that elegant numerical spiral found in sunflowers and nautilus shells, isn't just a pretty pattern. It's nature's way of optimizing space and growth, a design so efficient that architects and painters have mimicked it for millennia. DNA itself is a masterpiece of information storage, a double helix that coils with the precision of a Renaissance engraving. But here's the twist, it's also an imperfect copyist. Errors in replication, those tiny mutations, are the universe's way of experimenting. Most lead to dead ends, like a painter's discarded sketches, but occasionally one unlocks a new possibility. A protein fold that resists disease, a pigment molecule that camouflages a moth against soot-stained trees. Evolution doesn't plan ahead. It improvises, working with whatever materials are at hand, just as a mixed media artist might combine scraps of paper, paint, and found objects into something unexpectedly beautiful. The parallels between art and evolution go deeper than aesthetics. Consider how species adapt to niches, each filling a specific role in its ecosystem like instruments in an orchestra. The hummingbird's needle-like beak evolved to sip nectar, just as a calligrapher's brush adapts to the flow of ink. Predators and prey engage in an endless arms race, their adaptations mirroring the push and pull between artistic movements, Impressionism reacting to realism, modernism rebelling against tradition. Even extinction plays its part. The demise of dinosaurs cleared the stage for mammals, much as the fall of an empire might inspire a new cultural renaissance. What's most humbling is the timescale. Human artists might spend years on a single painting, but evolution works in millennia. The transition from fins to limbs, the development of feathers from scales, the slow calibration of a flower's color to attract pollinators, these aren't sudden strokes of genius. They're incremental adjustments, each generation adding a tiny brushstroke to a canvas that spans epochs. And just as art reflects its era, biology carries echoes of ancient worlds. The hiccup reflex traces back to our fish ancestors. The vestigial muscles that once made our ears twitch now serve no purpose, like an abandoned fresco peeking through layers of newer paint. This creative process isn't confined to the past. It's happening right now in the antibiotic resistance of bacteria, the shifting migration patterns of birds, even the way urban foxes are developing shorter snouts to scavenge human food. Evolution doesn't care about perfection, only viability. A peacock's extravagant tail might seem impractical, but if it attracts mates, it thrives. Similarly, art isn't judged by efficiency alone. A Baroque cathedral or a jazz improvisation might defy utilitarian logic, yet they resonate because they move us. Ultimately, evolution and art share the same driving force, the need to adapt, express, and endure. A coral reef's riot of color and a Kandinsky painting might seem worlds apart, but both are manifestations of a deeper truth, that creativity isn't a human invention. It's woven into the fabric of life itself, a language spoken in genes and pigments, equations and sonatas. Every living thing is both artist and artwork, shaped by time's patient hand. And that means you, watching this, are part of the masterpiece, a brushstroke in a painting still being made. Human consciousness might be the universe's most astonishing trick, not just the ability to think, but to step outside ourselves and ask, why are we here? Look at your hands for a moment. Those atoms, forged in dying stars, have somehow arranged themselves into a structure complex enough to question its own existence. We're not just stardust, we're stardust that wanders, and that changes everything. Some philosophers argue consciousness isn't a passive byproduct of evolution. It's an active participant in shaping reality, like a painter who steps back from the canvas only to realize they're part of the painting itself. Take quantum mechanics, where the act of observation alters the behavior of particles. A photon behaves as a wave until you measure it, then it chooses to act like a particle. It's as if reality remains fluid until a conscious mind crystallizes it, much like a sculptor deciding which angle of a block of marble to reveal. Artists understand this instinctively. A landscape isn't just light and shadow until someone frames it, interprets it, pours meaning into it. In the same way, the cosmos might not fully exist in a concrete sense until life emerges to witness it. The trees falling in an empty forest, if no one's there to hear, do they make a sound? Physics now whispers, maybe not. Yet consciousness isn't just a mirror reflecting reality, it's a prism refracting it into infinite possibilities. Consider how two people can stare at the same sunset. A physicist calculates wavelengths and atmospheric scattering, while a poet sees metaphors for mortality and renewal. Same light, entirely different experiences. The universe doesn't dictate meaning, it offers raw materials, and our minds assemble them into stories, equations, art. Even time itself might be malleable to perception. For a mayfly living one day, existence is a frenzied blur. For a bristlecone pine standing for 5,000 years, it's a slow exhale. Who's to say which experience is more real? This dance between observer and observed isn't new. Indigenous cultures have long spoken of dreams shaping the physical world, while Eastern philosophies dissolve the boundary between self and cosmos. Modern science edges toward similar ideas. The anthropic principle suggests the universe's constants are finely tuned because conscious life exists to notice them. Flip that around and it's staggering. If reality weren't structured just so, we wouldn't be here to question it. It's as if the cosmos conspired to create its own audience, an echo chamber where it can admire its handiwork. Artists and scientists alike chase this paradox. When a composer translates the chaos of emotion into structured sound, or a physicist writes equations to describe the birth of galaxies, they're doing the same thing, distilling the universe's complexity into forms the human mind can grasp. The irony, in trying to decode the masterpiece, we add new brushstrokes. Every telescope pointed at the stars, every poem scribbled at midnight, every child asking, "What's beyond the sky?" They're all part of the universe's unfolding creativity. So where does that leave us? Not as passive spectators, but as co-creators. The same neural networks that let you savor a melody or solve a puzzle also let you imagine alternate futures, empathize with strangers, or grieve a world you'll never see. That's the real magic. The universe didn't just arrange atoms into thinkers. It made thinkers who could rearrange atoms, who could turn sand into silicon chips, who could decode DNA and paint murals on the sides of skyscrapers. We're the universe's way of going beyond physics, into metaphor, into meaning. Maybe that's the answer to Fermi's paradox, the eerie silence of the cosmos. If consciousness is rare or fleeting, then we're not just lucky, we're necessary. Without minds to witness it, the universe would be a symphony played in an empty hall. But with us, it's a conversation, a give and take between stardust and sentience, where every thought, every discovery, every act of creation is the cosmos leaning closer and whispering, "You see it too, don't you?" Mathematics hums beneath the surface of reality like a silent symphony, orchestrating the spin of galaxies and the unfurling of rose petals with the same elegant equations. It's not just a tool for calculation, it's the universe's mother tongue, the invisible ink in which the cosmos writes its laws. Consider the Fibonacci sequence, where each number is the sum of the two before it. This simple pattern ripples through nature with breathtaking precision. The spiral of a sunflower's seeds, the curve of a nautilus shell, even the branching of trees in a forest. These aren't accidents, they're proof that beauty and logic share the same blueprint. Leonardo da Vinci knew this better than most. When he sketched the Vitruvian Man, he wasn't just drawing a figure, he was mapping the mathematical harmonies hidden in the human form. The ratio of a person's height to their arm span, the way a circle fits perfectly around our outstretched limbs, these proportions mirror the golden ratio, a number roughly 1.618 that appears in everything from Greek temples to hurricane spirals. Da Vinci saw math not as cold abstraction, but as the scaffolding of grace. His Last Supper uses linear perspective to pull viewers into the scene, proving that geometry could evoke awe as powerfully as any brushstroke. Even music, the most emotional of arts, dances to mathematics' tune. The intervals that make a chord pleasing octaves, fifths, thirds, are precise frequency ratios. Bach's fugues weave mathematical counterpoint into transcendent sound, while the vibrations of a violin string obey the same wave equations that describe light traveling through space. When scientists convert cosmic radio waves into audible tones, the resulting songs of planets and stars feel eerily melodic, as if the universe has been composing all along. What's truly astonishing is how math bridges the abstract and the tangible. Take fractals, infinitely complex shapes that repeat at every scale. Zoom into a Romanesco broccoli's florets, and you'll see the same spirals repeating like a recursive dream. Artists like M.C. Escher captured this eerie symmetry in his tessellations, where fish morph into birds in an endless loop, while modern architects use fractal algorithms to design buildings that mimic organic growth. The universe doesn't distinguish between art and equation. It simply unfolds according to patterns that delight both the calculator and the poet. This duality reaches its peak in the laws of physics. Einstein's E equals mc2 isn't just a formula. It's a haiku of energy and matter, a few symbols holding the secret of stars. When physicists describe quarks or black holes, they do so in equations that balance like sonnets, each term resonating with the next. Even the ugly math chaos theory, quantum probabilities, has its own wild beauty, like the splattered vitality of a Pollock painting. The universe doesn't care if we find its rules elegant, yet somehow, against all odds, we do. Perhaps that's the most profound mystery of all. Why should human minds, evolved to dodge predators and gather berries, be able to decipher the universe's mathematical code? It's as if we've stumbled upon a love letter written in a language we somehow understand, a shared dialect between cosmos and consciousness. Every time a child counts petals on a daisy or an astronomer measures a star's pulse, we're not just doing math. We're eavesdropping on creation's quietest, most perfect conversation. Symmetry is the silent architect of beauty, a principle so fundamental that it whispers through every layer of reality. Snowflakes crystallize into hexagonal perfection, each arm a mirror of the others, while galaxies spin in graceful spirals, their arms balanced like the spokes of a cosmic wheel. Physicists chase symmetry like detectives following clues, believing the universe's deepest laws must be elegant and balanced. Artists, whether painting a Renaissance portrait or designing a modernist skyscraper, instinctively arrange elements to create visual harmony. But this isn't just about aesthetics, it's about efficiency. Symmetry is nature's way of optimizing energy, structure, and even information. Take the human face. Studies show we're drawn to symmetrical features not because they're rare, but because they signal health and genetic fitness. A butterfly's wings mirror each other not for decoration, but because symmetry maximizes flight stability. Even the double helix of DNA coils with a rhythmic balance, its two strands twining in perfect partnership. This isn't coincidence, it's a universal preference coded into the fabric of existence. When physicists like Einstein sought equations to describe gravity or electromagnetism, they assumed the laws would be symmetrical, unchanged whether you're in New York or a galaxy a billion light years away. That assumption led them to relativity, a theory so beautiful it feels almost poetic. Art history echoes this obsession. The Taj Mahal's mirrored gardens, the Parthenon's proportional columns, even the radial symmetry of a stained glass rose window, all tap into a deep human craving for order. But here's the twist: absolute symmetry is sterile. The most captivating works introduce subtle asymmetries, like the slight tilt of Mona Lisa's smile or the irregular brushstrokes in Van Gogh's Starry Night. Nature does the same. A sunflower's seed spiral in near-perfect Fibonacci sequences, yet no two are identical. The universe adores symmetry, but it breathes through the cracks, those tiny flaws that make things feel alive. Quantum physics takes this further. At subatomic levels, particles have symmetrical twins. For every electron, there's a positron. For every quark, an antiquark. Yet our universe is made mostly of matter, not antimatter, a broken symmetry that might explain why we exist at all. Similarly, the Big Bang likely began in perfect symmetry, a state where all forces were unified. As the cosmos cooled, that symmetry froze out into the distinct forces we know today, like a molten crystal forming facets as it solidifies. The imperfections in that process, the cracks in the cosmic mirror, gave rise to stars, planets, and us. This dance between symmetry and asymmetry reveals a profound truth. Balance isn't about perfection, it's about tension. A perfectly symmetrical face might seem eerie, like a mannequin. Add a freckle or a crooked smile, and suddenly it's human. The universe operates the same way. The slight wobble in Earth's tilt gives us seasons. The asymmetry of a bird's wing beats creates lift. Even the imperfect symmetry of snowflakes, each one unique, allows them to form intricate patterns instead of bland uniformity. Perhaps that's why symmetry feels so deeply satisfying. It's not just a visual trick, it's a signature. When we gaze at a honeycomb's hexagonal cells or the spiral arms of the whirlpool galaxy, we're glimpsing the universe's handwriting, a language of balance written into atoms, organisms, and orbits. Science deciphers the grammar, art makes us feel its rhythm. Together, they remind us that symmetry isn't just a rule. It's the universe's way of winking at us, whispering, "You recognize this, don't you?" Because somewhere, deep down, we do. Entropy is the quiet force that ensures nothing stays the same, not the stars above us, not the paint on a canvas, not even the thoughts in our mind. It's the universe's way of whispering that all things must scatter, that energy dissipates, and order inevitably gives way to chaos. Yet within this seeming decay lies a paradox. Entropy doesn't just destroy. It creates. Think of a sandcastle washed away by the tide. The sculpture vanishes, but the grains themselves become part of new patterns, ripples on the ocean floor, dunes reshaped by wind. What looks like an ending is really a transformation, a rearrangement of the same pieces into something unexpected. Artists have always understood this dance between permanence and impermanence. The Japanese practice of wabi-sabi finds beauty in fleeting moments, a cracked teacup repaired with gold, the way sunlight filters through autumn leaves for just a few weeks each year. Even the great frescoes of the Renaissance, meant to last centuries, fade and crack, their pigments reacting to humidity and light. But this decay isn't failure, it's part of the story. The peeling layers of a medieval altarpiece reveal the artist's underdrawings, ghostly echoes of the creative process. Similarly, stars don't just burn out, they explode, seeding the cosmos with the elements that will one day form planets, oceans, and living things. Entropy isn't a villain. It's the universe's way of recycling its materials, like a sculptor melting down old bronze to cast something new. Science frames this as the second law of thermodynamics. In any closed system, disorder increases over time. Yet that very disorder fuels complexity. A cup of hot coffee cools to room temperature, its heat energy dispersing into the air, a simple example of entropy at work. But zoom out, and you'll see how that same principle drives hurricanes, powers engines, and even allows your brain to think. Neurons fire in unpredictable patterns, creating thoughts from what should be noise. The universe thrives on this balance between chaos and order, much like jazz musicians weaving melodies from improvisation. Consider the fate of our own solar system. Billions of years from now, the Sun will expand, scorching Mercury and Venus, then collapse into a white dwarf. Earth's mountains will erode, its oceans evaporate. Yet even in this distant future, entropy won't mean stillness. Atoms now locked in rock will drift through space, perhaps joining new nebulae where gravity pulls them into fresh constellations. The same force that unravels also reassembles, like a painter scraping away a failed sketch to begin anew. This duality resonates deeply with human creativity. Tibetan sand mandalas, intricate and laborious, are swept away upon completion, a meditation on impermanence. Street artists know their murals will fade under sun and rain, yet they paint anyway, embracing the temporary. Even digital art, seemingly eternal, faces entropy in its own way. File corruption, obsolete formats, the slow decay of storage devices. Nothing escapes the pull of time, and that's precisely what gives creation its urgency and meaning. So the next time you see a fallen leaf crumbling into soil or a candle flame guttering out, remember, entropy isn't the end of the story. It's the universe's method of storytelling, a reminder that every ending carries the seeds of something else. Stars die so planets can form, paint cracks so restorers can uncover lost histories, and the heat death of the universe itself, that's just the final brushstroke on a canvas we're still learning to see. Neutron stars are cosmic alchemists, crushing matter into forms so dense a single teaspoon would weigh 1 billion tons on Earth. Picture a star 10 times more massive than our Sun, collapsing inward until its protons and electrons fuse into neutrons, packing all that fury into a sphere no wider than Manhattan. The result isn't just a dead star, it's a celestial diamond, spinning faster than a blender blade and humming with gravitational waves that ripple through space-time like vibrations from a tuning fork. What's astonishing isn't just their density, but their precision. Some neutron stars, called pulsars, beam radiation from their poles with such clockwork regularity they rival atomic clocks. Imagine a lighthouse sweeping the cosmos, its light pulsing every millisecond without fail. Artists chasing perfection might spend lifetimes refining a single brushstroke, yet here's nature, sculpting spinning beacons so exact they could guide interstellar travelers. The Crab pulsar, born from a supernova observed in 1054, still spins 30 times per second, a relentless metronome echoing across nearly a millennium. But neutron stars aren't just precise, they're violent poets. When two of them spiral into each other, their collision unleashes energy so immense they forge gold, platinum, and other heavy elements in a heartbeat. The gravitational waves from such an event, detected for the first time in 2017, sent shudders through detectors on Earth. It was like hearing the universe's hammer strike an anvil, reshaping raw matter into cosmic jewelry. The gold in your ring, the uranium-powering reactors, likely born in moments like these, where extreme conditions become crucibles of creation. Their surfaces defy imagination too. The crust, a crystalline lattice of iron nuclei, floats atop a superfluid sea of neutrons so slippery it has zero viscosity. Magnetic fields trillions of times stronger than Earth's twist this landscape into peaks and valleys, creating stresses that crack the crust in starquakes, cosmic tremors releasing bursts of X-rays. It's as if the star is a living canvas, its surface fracturing and healing in cycles of destruction and renewal. Yet for all their ferocity, neutron stars possess an eerie beauty. Their gravitational fields bend light into mesmerizing halos, an effect physicists call lensing. Seen from afar, they'd warp the starlight behind them into rings, like a cosmic version of the radiant coronas in medieval religious paintings. Even their formation carries a tragic elegance. The supernova explosion that births them scours the surrounding space with light so brilliant it outshines entire galaxies for weeks, a final, dazzling brushstroke before the star contracts into its dense, luminous core. Perhaps the most profound lesson they offer is this: extremes don't have to be destructive. Neutron stars thrive on the edge of impossibility, balancing unimaginable pressure with delicate rotation, chaos with perfect rhythm. They're proof that the universe doesn't just tolerate intensity, it harnesses it, turning collapse into precision, violence into creation. Every time a pulsar's beam sweeps past Earth, it's not just a dead star's cry. It's a reminder that even in the harshest corners of reality, there's a pulse, a stubborn, beautiful refusal to fade quietly into the dark. Panspermia whispers a tantalizing possibility, that life didn't originate on Earth at all, but hitchhiked here aboard comets or meteorites, a cosmic stowaway in the grand voyage of the universe. If microbes can survive the void between worlds, drifting for eons until they find fertile ground, then creativity itself might not be an earthly invention, but a universal inheritance. Imagine the first stirrings of consciousness, the first pigments smeared on cave walls, the first melodies hummed under starlight. What if those sparks weren't born here, but carried here, part of an ancient lineage stretching back to some distant, long-vanished ocean under an alien sun? This idea transforms how we see art's origins. The same organic compounds found in asteroids' amino acids, the building blocks of proteins, are also the foundation of every thought, every emotion, every brushstroke. When a composer writes a symphony or a poet wrestles with metaphor, they might be channeling chemistry older than our solar system, molecules forged in interstellar clouds now rearranged into sonnets and sculptures. The cave paintings at Lascaux, the intricate carvings of Mesopotamia, even the digital art lighting up screens today, all could be distant echoes of a creative impulse seeded across the cosmos. Consider the humble tardigrade, a microscopic creature that can survive the vacuum of space, its DNA repairing itself even after brutal radiation exposure. If life this resilient exists on Earth, why not elsewhere? And if life can travel, why not the raw materials of creativity, the curiosity, the problem-solving, the need to express? On some distant exoplanet, a being with entirely different biology might gaze at its night sky and feel the same pull to capture the ineffable, to turn stardust into story. The implications ripple outward. If Panspermia is true, then art isn't just a human endeavor, it's a cosmic one. The spiral motifs in Celtic knots and the arms of distant galaxies, the rhythmic pulses of tribal drums and the radio waves pulsating from neutron stars, these parallels might be more than coincidence. They could be evidence of shared patterns, universal languages written into the fabric of life itself. Even our myths resonate with this idea, Prometheus stealing fire from the gods, or the Norse belief that humans were carved from driftwood. These stories hint at an instinctual understanding that we're made of borrowed materials, shaped by forces beyond our world. Science inches closer to testing this theory. The discovery of ribose, a sugar essential for RNA, on meteorites suggests that the ingredients for life rain down constantly. Meanwhile, experiments on the International Space Station show bacteria surviving years in open space, bolstering the case for interstellar hitchhiking. If life truly moves between worlds, then creativity, the drive to make meaning from chaos, might be as fundamental to the universe as gravity or light. So the next time you feel a surge of inspiration, a fleeting idea that seems to come from nowhere, consider this. It might not be nowhere at all. It might be a whisper from the void, a fragment of some ancient, star-born impulse passed down through cosmic generations. Art, then, isn't just a human act. It's the universe remembering itself, rearranging its own stardust into something new, something beautiful. And that makes every song, every painting, every story a collaboration across time and space, a dialogue between Earth and the infinite. The anthropic principle tugs at a profound mystery. Why does the universe seem meticulously calibrated to allow life, and by extension, observers who can ponder its beauty? The constants of nature are balanced on a knife's edge. If gravity were slightly stronger, stars would burn out too quickly. If the electromagnetic force were weaker, atoms couldn't bond. Carbon, the backbone of life, exists only because of a precise resonance in the nuclear reactions of stars. It's as if the cosmos conspired to create conditions where eyes could open, look skyward, and gasp at the spectacle. This fine-tuning echoes an age-old artistic dilemma. Does a painting truly exist if no one sees it? Philosophers like George Berkeley argued reality depends on perception. To be is to be perceived. The universe, in this light, might not just tolerate observers, it requires them. Think of a tree falling in an empty forest. Without ears to hear, does it make a sound? Physics now poses a similar riddle. Without consciousness to measure it, does the quantum world remain a haze of probabilities? The act of observation collapses wave functions, turning might be into is. It's as if reality sharpens into focus only when life leans in to look. Artists have always grappled with this interplay between creator and audience. A playwright crafts dialogue, but the lines don't fully live until actors speak them and an audience laughs or weeps. The universe, too, might be an unfolding performance waiting for witnesses. The spiral arms of galaxies, the fractal branching of rivers, the shimmering auroras, these aren't just accidents of physics. They're invitations to awe, as if the cosmos yearns to be noticed. The Hubble telescope's deep-field images, revealing thousands of galaxies in a patch of sky the size of a grain of sand, aren't just data. They're a mirror held up to the universe, and in that reflection, the universe sees itself. Yet here's the twist: the anthropic principle doesn't necessarily imply design. Some scientists argue we're survivors of a cosmic lottery. Countless universes may exist, each with different constants, and we simply inhabit the one where the numbers lined up right. But even this multiverse scenario carries poetic weight. If every possible universe exists, then ours is the rare gem where matter woke up and began telling stories. The fact that we're here to debate it, to paint murals, compose concertos, and launch telescopes, suggests something extraordinary. Beauty isn't just in the eye of the beholder is part of the beauty. Consider how art transforms when shared. A sculptor shapes marble alone, but the statue's meaning multiplies with each viewer's interpretation. Similarly, the universe's grandeur isn't diminished by being observed, it's amplified. The colors of a sunset aren't less real because our eyes evolved to see them. They're more vivid because we can name them, photograph them, and weave them into sonnets. Science measures the wavelengths of light, but art captures the lump in your throat when the sky burns gold. Perhaps that's the ultimate answer to why the constants align as they do. Not because of a watchmaker deity, not because of infinite cosmic dice rolls, but because existence at its core is relational. The universe isn't a static artifact. It's a conversation, an endless exchange between the physical and the perceptual, the quantifiable and the felt. When a neuron fires in your brain as you gaze at the Milky Way, you're not just a bystander. You're the universe observing itself, a brushstroke in its own masterpiece, asking the oldest question of all: what does it mean to be here? And in that asking, the answer takes shape. Cosmic inflation was the universe's boldest opening act, a burst of expansion so rapid it defies intuition. In less time than it takes light to cross a single atom, space itself stretched from smaller than a proton to the size of a grapefruit, smoothing wrinkles in spacetime like an artist priming a canvas. This wasn't just growth, it was a creative explosion, setting the rhythm for everything from galaxy clusters to the veins in a leaf. The equations describing inflation might look sterile on paper, but their implications are breathtaking. Without that sudden stretching, matter would have clumped unevenly, stars might never have ignited, and the cosmos could have collapsed back into nothingness before it even began. Think of it like a potter throwing clay onto a wheel. That first centrifugal tug determines the shape of the entire vessel. Too weak, and the clay collapses. Too strong, and it flies apart. Inflation was the universe's perfect spin, a balancing act between runaway expansion and gravitational pull. The microscopic quantum fluctuations during that fleeting moment weren't just noise, they became the blueprints for galaxies. Where space stretched slightly denser, gravity pooled matter into cosmic cities. Where it stretched thinner, vast voids formed. The universe's largest structures, in other words, are magnified imprints of its tiniest beginnings. Artists understand this intimacy between first strokes and final masterpieces. Leonardo da Vinci's underdrawings, those faint charcoal lines beneath the Mona Lisa, guided every layer of paint that followed. Similarly, inflation's imprint lingers in the cosmic microwave background, that faint glow from the early universe often called its baby picture. The subtle variations in temperature, hotter reds and cooler blues aren't random. They're the brushstrokes of inflation, frozen in time like a sketch preserved beneath oil paint. Yet inflation's creativity didn't stop at structure. It also solved cosmic mysteries with elegant flair. Before inflation, physicists puzzled over why the universe looked so uniform in all directions, like a mural painted with unnervingly consistent texture. Inflation stretched space so swiftly that even distant regions once in contact were torn apart, leaving matching patterns across the sky like repeating motifs in a tapestry. It even explains why we don't find bizarre relics like magnetic monopoles particles predicted by theory but never observed. Inflation diluted them to near non-existence, sweeping cosmic clutter under the rug with the efficiency of an editor trimming a draft. The parallel to artistic process is uncanny. Just as a writer might scrap entire chapters to preserve a story's flow, or a composer might silence one instrument to highlight another, inflation edited the universe's raw materials into coherence. The difference, while human creators labor over revisions, the cosmos performed its edits in a fraction of an eye blink with no second drafts. What's most humbling is how this primordial creativity echoes forward. The same exponential growth that smoothed the early universe now finds echoes in nature's designs, the unfurling of fern fronds, the branching of neurons, even the accelerating expansion of dark energy in our current epoch. Inflation wasn't just a one-time event. It set a precedent, a rhythm of stretching and refining that still resonates. The universe, it seems, has always been an artist at heart, beginning with a single, decisive stroke, then spending billions of years filling in the details. Gravitational lensing twists the fabric of reality itself, bending light like a prism pressed against the eye of the cosmos. Picture a galaxy billions of light years away, its light traveling through the void for eons, only to be warped and magnified by an invisible hand as it passes a massive cluster of galaxies. The result, a celestial funhouse mirror, where distant starlight stretches into glowing arcs, rings, and even duplicate images, as if the universe couldn't resist sketching its own reflection. This isn't science fiction. It's Einstein's general relativity in action, proving that space isn't just empty, it's a dynamic canvas where gravity sculpts with light. The most striking lenses resemble works of abstract art. The Einstein cross, for instance, appears as four perfect copies of the same quasar, arranged around a central galaxy like petals on a flower. Then there's the Horsehoe ring, where a distant galaxy is stretched into a near-complete circle, a halo of stardust wrapped around the lensing cluster like a cosmic wedding band. These aren't random distortions, they follow precise mathematical rules, revealing the mass of the foreground object like an X-ray revealing bones beneath skin. Scientists use these cosmic mirages to map dark matter, tracing its invisible grip by how it bends the light behind it. But lensing isn't just a tool for astronomers, it's a window into the universe's playful side. Some lenses create galaxy arcs, where spiral galaxies smear across the sky like brushstrokes left wet on canvas. Others produce ghost images, where a single supernova flickers multiple times in different positions, its light taking alternate paths around the gravitational well. The most extreme examples, like the cluster nicknamed El Gordo, warp spacetime so dramatically they act as natural telescopes, magnifying objects too faint to see otherwise. It's as if the universe handed us a looking glass to peer deeper into its own history. The artistic parallels are uncanny. The way a glass paperweight distorts the view of a table beneath it mirrors how galaxy clusters bend light. The surreal landscapes in Dali's paintings, where clocks melt and figures stretch, feel eerily prophetic of lensed galaxies. Even the halos in medieval religious art, glowing rings around saints' heads echo the luminous rings created by perfect alignment between source, lens, and observer. Nature's lensing doesn't just resemble art, it is art crafted by gravity's invisible hand. What's truly humbling is how this phenomenon bridges scales. The same physics that bends starlight around a galaxy also governs how your glasses focus light onto your retina. A droplet of water refracting sunlight into a rainbow operates on the same principles as a black hole lensing distant quasars. The universe repeats its patterns from the microscopic to the galactic, as if to remind us that creativity isn't confined to human hands. Gravitational lensing does more than reveal hidden corners of the cosmos. It transforms the night sky into an interactive exhibit where every massive object becomes both artwork and artist, bending light into shapes that blur the line between science and spectacle. When Hubble captures these cosmic mirages, we're not just seeing galaxies. We're witnessing the universe curating its own gallery, one where the frames are made of space-time and the paintings are written in starlight. Exoplanets spin through the cosmic dark like undiscovered masterpieces, each one a world waiting for its story to be told. Scientists have catalogued thousands of these distant planets, gas giants with skies of molten sapphire, rocky worlds where lava tides pulse like a heartbeat, even diamond planets where crushing pressure crystallizes carbon into glittering crusts. But here's the magic. Every detection is just a shadow on a graph, a wobble in starlight. It's artists who give these worlds color and texture, painting clouds where rain might fall as liquid metal or imagining forests of silica trees swaying under twin suns. Together, science and art transform data points into places you can almost feel. The gravitational tug of a super-Earth, the eerie glow of a tidally locked planet where one side forever faces its star. Some exoplanets defy even the wildest canvases. Take WASP-76b, where iron vaporizes in the scorching dayside and condenses into metal rain on the frigid night. Or HD 189733b, a cobalt blue world lashed by winds so fast they'd flay steel. Then there's Kepler-16b, orbiting two stars like Luke Skywalker's Tatooine, except instead of desert, it's a frozen gas giant where sunsets cast double shadows. These aren't just curiosities, they're proof that nature's imagination dwarfs our own. While artists sketch floating mountains or skies streaked with auroras, the universe has already sculpted realities far stranger. The hunt for exoplanets mirrors the creative process itself. Astronomers use tools like the James Webb Space Telescope to sniff out atmospheric chemicals, water vapor, methane, even potential biosignatures like detectives analyzing a palette for clues. A slight dip in light as a planet transits its star becomes the first stroke of a portrait. Meanwhile, digital artists like Lynette Cook or Nas, our own conceptual illustrators, take those sparse details and weave them into vistas where ammonia oceans churn under violet skies or fungal towers rise in low gravity. It's a dialogue. Science asks what's there, and art dares to ask what could be. What's most thrilling is how ordinary some alien worlds might feel. Kepler 452b orbits a sun-like star in the habitable zone, a rocky planet basking in light not so different from ours. Gliese 581d might have deep oceans beneath ice shields, echoing Antarctica's hidden lakes. These worlds tug at our longing for kinship, the hope that somewhere another planet has weathered its own storms, nurtured its own beauty, perhaps even gazed back at the stars with wonder. Exoplanets remind us that the universe isn't just vast, it's alive with possibility. Every new discovery is a blank canvas, a fresh what-if waiting to be explored. Whether through the precision of spectroscopy or the brushstrokes of a dreamer, these distant worlds invite us to see beyond the limits of our pale blue dot. They're not just points of light, They're promises that no matter how much we learn, the cosmos will always have one more secret, one more story, one more masterpiece spinning in the dark. Dark energy is the universe's most enigmatic muse, an invisible force stretching the cosmos apart with a vigor that defies gravity itself. Imagine blowing up a balloon with dots on its surface. As the balloon inflates, the dots drift farther apart. Now picture that balloon expanding faster and faster, as if some unseen hand were pumping air with increasing urgency. That's dark energy in action, accelerating the universe's expansion so relentlessly that distant galaxies now flee from us faster than light can bridge the gap. Yet for all its power, dark energy leaves no fingerprints. It doesn't clump like matter, reflect like light, or collide like particles. It's a shadow in the equations, a cosmic whisper that says, there's more here than you can see. This mystery mirrors the creative process in uncanny ways. Think of a painter standing before a blank canvas, gripped by an urge they can't quite name, a compulsion to create that defies logic yet feels as inevitable as the tide. Dark energy is the universe's version of that ineffable drive. Just as an artist might not understand where inspiration comes from, physicists can't yet explain why dark energy exists or how it works. They measure its effects the way supernova dim faster than expected, or how galaxy clusters seem to be yanked apart, but its essence remains elusive. It's the ultimate blank space in our cosmic map, a question mark hanging over the fate of everything, yet within that uncertainty lies a strange beauty. Dark energy doesn't just push galaxies away, it shapes the future of reality itself. Without it, gravity would eventually pull all matter into a big crunch, a fiery collapse echoing the Big Bang in reverse. Instead, dark energy ensures the universe will keep expanding, growing colder and emptier until the last stars flicker out. It's a reminder that endings aren't passive, they're sculpted by forces we're only beginning to grasp. The same could be said of art. A novel's climax, a symphony's final note, or the last brushstroke on a mural. These aren't accidents. They're guided by invisible currents of intuition and intent, the artist's own version of dark energy. The parallels deepen when you consider how both dark energy and creativity challenge our tools. Astronomers hunt dark energy with telescopes and supercomputers, just as artists chase inspiration through sketches, drafts, and experiments. The Hubble constant, which measures the universe's expansion rate, has been refined for decades, yet stubborn discrepancies remain. Similarly, an artwork might go through countless revisions, each one edging closer to a vision that's felt but never fully seen. Both endeavors require a tolerance for ambiguity, a willingness to dwell in the unknown. What's truly humbling is how dark energy forces us to confront the limits of human perception. Over 90% of the universe's energy content is invisible dark energy and its cousin, dark matter. We're like ants tracing the grooves on a vinyl record, unaware of the music those grooves contain. Artists face a similar paradox. The most profound works often emerge from what isn't said, the negative space in a sculpture, the silence between musical notes, the unspoken tension in a play's subtext. Dark energy is the universe's negative space, the unseen hand that shapes the scene. Perhaps that's why both dark energy and great art leave us awestruck. They remind us that reality is more than what meets the eye, that the deepest truths often lurk in the gaps, the questions, the unfinished edges. Whether through a telescope or a poem, we're reaching toward something vast and mysterious, something that refuses to be pinned down. And in that reaching, we touch the sublime, the dizzying sense that the universe, like the best art, is always one step ahead of us, always leaving room to wonder. The silence of the cosmos isn't just absence, it's a canvas. The Fermi paradox asks why, in a universe so vast and ancient, we haven't found a single whisper of extraterrestrial civilization. But what if that silence isn't an accident? Artists know the power of negative space, the way a painter might leave a portion of the canvas untouched to draw attention to what's there, or a composer might use silence to make the next note pierce deeper. The universe's quiet could be its own kind of statement, a deliberate pause in the cosmic dialogue that forces us to lean in and listen harder. Consider the great filter theory, the idea that some catastrophic barrier prevents life from advancing far enough to colonize the stars. Perhaps civilizations rise only to crumble under war, climate collapse, or runaway technology. If true, the silence isn't just eerie, it's a warning etched in the void, a galactic memento mori. Or take the zoo hypothesis. Maybe advanced species observe us from a distance, like curators preserving a wilderness area, waiting for humanity to reach a maturity worth engaging. In this light, the quiet isn't emptiness, it's restraint, a universe holding its breath. The parallels to art are uncanny. John Cage 4:33, a composition of pure silence, taught audiences that the absence of sound could be its own music. The rustling of clothes, the hum of air conditioning, the pulse of one's own breath. Similarly, the Fermi paradox reframes the universe's silence not as a failure of detection, but as an invitation to reconsider what communication even means. Alien signals might not be radio waves but something subtler, the rhythmic dimming of stars engineered into patterns, or neutrinos modulated like Morse code. We might be surrounded by messages we lack the senses or the science to decode. Even the act of searching mirrors artistic process. SETI scans the skies like a poet scanning a blank page for the right word, while projects like METI actively broadcast messages into the dark, a cosmic version of tossing a bottle into the ocean. Both endeavors are acts of faith, rooted in the same creative impulse that drives a painter to splash color onto canvas or a novelist to send characters into the unknown. The universe's silence, then, isn't passive. It's participatory, demanding we become not just observers but collaborators, filling the void with our own questions, our own art, our own stubborn hope. Perhaps the answer to the Fermi paradox lies in perspective. On a timeline spanning billions of years, civilizations might flicker in and out of existence like fireflies in the night, their signals crossing paths too rarely to catch. Or maybe we're early to the party, the first audience in a theater still setting up for the main act. The silence isn't empty, it's pregnant with possibility, a prologue waiting for its story to unfold. And that changes how we listen. Every quiet moment becomes a question, every star a potential punctuation mark in a conversation we're only just beginning to understand. Interstellar dust swirls through the cosmos like powdered pigment scattered across an artist's workshop, seemingly insignificant, yet transformative. These microscopic grains, no larger than smoke particles, are the universe's pastel palette, softening starlight into dreamy hues of rose, lavender, and aquamarine. When light from a newborn star pierces a cosmic dust cloud, shorter blue wavelengths scatter more easily, painting the surrounding gas in ethereal cerulean, while longer red tones diffuse into warm coral glows. The result, nebulae that resemble watercolor washes bleeding across the void, their delicate gradients stretching light years wide. The Orion Nebula's pink tendrils or the Veil Nebula's sapphire filaments aren't just accidents of physics. They're proof that even the universe's debris is laced with artistry. Zoom in on one of these dust grains and you'll find a speck of something extraordinary. Silicates, carbon compounds, even tiny diamonds forged in the hearts of dying stars. Each particle is a time capsule carrying the remnants of ancient supernova or the outer layers of red giants that shed their skins like autumn leaves. When these motes drift together, they don't just block light, they sculpt it. Dust clouds act like celestial stained glass, filtering and refracting starlight into intricate patterns. The Horsehead Nebula's Inkai silhouette isn't a hole in space. It's a dense knot of dust backlit by glowing gas, a shadow puppet cast against a cosmic lantern. What's mesmerizing is how dust mirrors the creative process itself. Just as a painter layers washes of translucent pigment to build depth, cosmic dust accumulates in veils, each stratum subtly altering the light that passes through. The pillars of creation in the Eagle Nebula, those towering columns immortalized by Hubble, owe their drama to this very effect. Their edges glow gold where young stars irradiate the dust, while their shadowy cores hide stellar nurseries, the dust acting as both curtain and cradle. Even destruction becomes art here. When shock waves from exploding stars rip through dust clouds, they compress and heat the grains, triggering new rounds of star formation. It's as if the universe can't resist recycling its materials, turning the ashes of old suns into the seeds of new ones. The colors we see in nebulae are more than eye candy, they're cosmic chemistry in action. Oxygen atoms excited by starlight emit a signature green glow, while hydrogen paints regions red like neon signs in a foggy night. Sulfur adds mustard yellow accents, and nitrogen tinges edges with fiery orange. These elements don't just float freely, they cling to dust grains, which act as tiny laboratories where molecules can meet and bond. Some of the most complex organic compounds in space, including precursors to amino acids, form on these microscopic surfaces. The same dust that paints the sky might also carry the building blocks of life. Artists have long chased these otherworldly hues. Turner's sunsets, awash in luminous peach and cobalt, unknowingly mimicked the light-scattering effects of interstellar dust. Modern astrophotographers, like digital age impressionists, use narrowband filters to isolate and amplify these emissions, transforming raw data into portraits of the cosmos that feel both scientific and sublime. Even the James Webb Space Telescope's infrared eyes pierce through dust veils, revealing structures hidden to optical telescopes, proof that beauty shifts depending on how you look. Dust isn't just the universe's medium, it's its memory. Every fleck carries the history of its origins, the violent death of a star, the gentle drift through millennia, the eventual collapse into a new solar system. When you gaze at the Milky Way's hazy band arching overhead, you're not just seeing stars, you're seeing the accumulated breath of countless suns, the finely ground residue of cosmic alchemy. And in that dust, the universe whispers its oldest secret, that destruction and creation are the same stroke of the brush, the same note in the song. The canvas is never blank, it's always waiting for the next light to scatter, the next color to bloom. The Hubble Deep Field is more than a photograph, it's a keyhole into the infinite. In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky no larger than a grain of sand held at arm's length. A region so seemingly empty it was chosen precisely because it appeared devoid of stars. What came back was anything but blank. Over 10 consecutive days, Hubble gathered faint light from the deepest reaches of the cosmos, revealing a staggering truth. That tiny, empty slice of space contained not just a few distant galaxies, but thousands, each one a swirling island of billions of stars, some so ancient their light had traveled nearly the entire age of the universe to reach us. The image that emerged wasn't just data, it was a portal, a cosmic tapestry stretching back to the dawn of time. What makes the deep field transcendent is how it collapses scale. Those smudges of light, some spiral, some elliptical, some irregular blobs, aren't just galaxies, they're stories. The faintest, most redshifted specks are infant galaxies as they look just a few 100 million years after the Big Bang, their blue stars blazing with youthful intensity. The closer, brighter spirals resemble our own Milky Way in its prime, their arms thick with stellar nurseries. And between them, the void isn't truly void. It's threaded with the faint glow of galaxies too distant for even Hubble to resolve. A reminder that every empty space in the image is an illusion, a limit of our tools rather than the universe's generosity. This image didn't just advance science, it rewired our intuition. Before the deep field, many assumed the universe was relatively homogeneous on large scales. But here was proof that galaxies stretched on forever, that no matter how deep we looked, there would always be more. It's the visual equivalent of standing on a shore and realizing the ocean extends beyond the horizon, except the ocean has no end. The Hubble Deep Field is humbling not because it makes us feel small, but because it reveals a cosmos so vast that small and large lose meaning. We're not insignificant, we're participants, one note in a symphony with no final measure. Artistically, the deep field operates like a Renaissance masterpiece. Its composition is deceptively simple, a black backdrop studded with glowing forms, yet its depth is inexhaustible. The longer you look, the more you see. Galaxies colliding in slow motion, their shapes distorted by gravitational tides, distant quasars blazing like beacons, delicate arcs of light bent by invisible dark matter. The color palette, though enhanced for scientific clarity, feels eerily deliberate. Deep indigos for the oldest light, golden hues for mature galaxies, and ruby-red streaks where star formation runs hot. It's as if the universe curated its own gallery, arranging aeons of history into a single frame. The deep field's legacy isn't just in what it revealed, but in how it changed us. It's a mirror held up to human curiosity, proof that staring into the void isn't folly, it's how we find our place in the story. When Michelangelo painted the Sistine Chapel's ceiling, he aimed to capture the divine. Hubble's deep field does something similar, but its divinity isn't in heaven's imagined, it's in heaven's real, a testament to the fact that the universe doesn't need metaphor to inspire awe. It simply is, in scales and splendors that defy comprehension. And in that defiance, it invites us to keep looking, keep questioning, keep reaching for the next keyhole, because infinity, it turns out, has no edges. Astrobiology doesn't just ask whether life exists beyond Earth, it wonders what that life might mean. If microbes thrive in the acidic clouds of Venus or beneath the icy crust of Europa, do they simply survive, or do they, in their own way, create? The search for extraterrestrial life often focuses on chemical signatures, methane spikes, oxygen imbalances, but what about the signatures of imagination? Art at its core is the rearrangement of the ordinary into something that stirs the senses. If an alien organism sculpts its environment, communicates in patterns beyond mere utility, or responds to beauty, does that count as creativity? The question isn't frivolous. It forces us to redefine life not just as a biological process, but as a cultural one. Consider the bowerbird on Earth, weaving intricate nests adorned with shells and berries to attract mates. Or the fractals of a snowflake crystals following mathematical rules, yet each one unique. These aren't art as humans define it, but they're not art either. Now imagine a silicon-based organism on Titan, etching intricate patterns into frozen methane dunes as part of a mating ritual. Or a colony of microbial mats on Mars that secrete pigments in response to sunlight, painting the subsurface in fleeting, radiant swirls. The universe might be teeming with expressions we haven't learned to recognize, forms of creativity that don't require brushes or sonnets but emerge from the same impulse to make the invisible visible, to leave a mark. Scientists hunting for life often look for biosignatures, molecules or structures that betray biology's handiwork. But what about ether signatures, the deliberate arrangement of matter or energy that serves no survival purpose other than to evoke, to communicate, to transcend? On Earth, we've found cave paintings dating back 40,000 years, proof that consciousness quickly turns toward symbolism. If another species out there gazes at its night sky, does it feel compelled to capture the swirl of its galaxy in song, in sculpture, in some medium we can't yet fathom? The Voyager Golden Record, with its encoded greetings and music, assumes that emotion and artistry are universal languages. But what if alien creativity operates on frequencies we're deaf to? The challenge is one of perception. Human art relies on senses shaped by our environment, eyes tuned to visible light, ears attuned to specific sound waves. A creature that sees through electrical fields or hears through vibrations in liquid methane might create works incomprehensible to us. Their masterpiece could be a pulsating magnetic field, a symphony of temperature gradients, or a scent so complex it tells stories. The jellyfish-like beings theorized to float in the atmospheres of gas giants might communicate through bioluminescent displays, turning their bodies into living murals that shift with the currents. Art in such a context isn't separate from life, it's life's exhalation. Yet even if alien creativity exists, could we recognize it? SETI scans for radio waves, but what if another civilization's equivalent of Mozart composes in neutrino bursts? Our telescopes map exoplanet atmospheres, but what if their painters work with atmospheric chemistry, using storms as brushes and auroras as pigments? The very act of searching for alien art forces us to confront the limits of our own imagination. We're like ants trying to comprehend a symphony, aware of vibrations, but missing the music. Perhaps the most profound implication is this: if creativity arises independently across the cosmos, it suggests that beauty isn't a human invention, but a universal tendency. The laws of physics favor certain patterns, spirals, symmetries, harmonics that recur from galaxies to seashells. If life elsewhere echoes these patterns in its own expressions, then art isn't just something we make. It's something the universe does through us, a continuation of the same impulse that arranges stars into constellations and atoms into DNA. The search for cosmic creativity isn't just about finding aliens. It's about understanding whether the urge to create is woven into the fabric of existence itself, a whisper of something deeper than survival, older than language, as infinite as the cosmos. The James Webb Space Telescope doesn't just observe the cosmos, it peels back time itself, revealing the universe's earliest brushstrokes with unprecedented clarity. Imagine uncovering the underpainting of a Renaissance masterpiece, where the artist's first tentative lines and compositional choices suddenly become visible beneath layers of glaze. That's what Webb achieves on a cosmic scale. Its infrared eyes pierce through cosmic dust, the universe's equivalent of yellowed varnish, to expose galaxies as they existed just 200 million years after the Big Bang. These aren't the majestic spirals we know today, but fragile, blobby structures glowing like embers in the dark, their light stretched and reddened by 13 billion years of expanding space. What makes Webb's images so revolutionary is how they transform raw data into emotional experience. Take the Carina Nebula's cosmic cliffs, where towers of gas and dust 3 light-years high glow like a watercolor lifted from its page. The telescope's near-infrared camera didn't just map molecular hydrogen, It captured the delicate veining of stellar nurseries, where newborn stars flicker behind diaphanous curtains of cosmic silt. Or consider the Southern Ring Nebula, its dying star ejecting iridescent shells of gas that Webb renders in pearlescent pinks and blues, not arbitrary choices, but false color translations of specific chemical emissions that our eyes could never see unaided. This isn't illustration, it's revelation, where wavelengths become hues and data transforms into awe. The telescope's very design mirrors artistic principles. Its 18 hexagonal mirrors, aligned to within nanometers, function like a pointillist's careful dabs of paint individual components, vanishing into a seamless whole. The sunshield, unfolding like origami in space, protects Webb's vision just as a painter might squint against glare to better judge tones. Even its orbit at Lagrange point 2, balanced between Earth's and the Sun's gravity, reflects the careful equilibrium of a mobile sculpture suspended in perfect tension. Webb's discoveries challenge both science and aesthetics. The abundance of early galaxies, some larger and more mature than models predicted, has forced astronomers to reconsider cosmic evolution, much as the discovery of perspective upended medieval art. Meanwhile, public reactions to its images reveal something profound. Humans instinctively recognize beauty in universal patterns. The Tarantula Nebula's swirling filaments trigger the same neural responses as Van Gogh's Starry Night because both tap into nature's shared vocabulary of turbulence and flow. This interplay between precision and poetry defines Webb's legacy. When it detects water vapor in an exoplanet's atmosphere or carbon dioxide on a world 700 light-years away, it's not just collecting data, it's adding pigment to the canvas of understanding. The telescope operates like the ultimate interdisciplinary artist, blending spectroscopy with sculpture, physics with fresco. Its images don't just show us the universe's past. They invite us to witness the ongoing masterpiece, where every observation is both a measurement and a meditation, a reminder that to study the cosmos is to participate in its unfolding story. The universe doesn't choose between art and science. It lives in the hyphen between them, a place where equations sing and stardust dances. Every law of physics holds the precision of a sonnet, while every swirling nebula bursts with the spontaneity of a Pollock painting. We've traced the arcs of planets like brushstrokes on a canvas, decoded the harmonics of atoms as if they were musical notes, and yet, the deeper we look, the clearer it becomes. Reality isn't just governed by rules. It's inspired by them. Take something as simple as a snowflake. Under a microscope, its hexagonal symmetry mirrors the crystalline structure of a diamond or the honeycomb lattice of a graphene sheet, proof that nature works from the same blueprint across scales. But no two snowflakes are alike. The same physics that dictates their six-fold symmetry also allows for infinite variation, a dance of temperature and humidity that turns each flake into a fleeting sculpture. Science explains the how, but art captures the wonder, the way a single snowflake melting on your glove feels like holding the universe's smallest masterpiece. Or consider the human brain, where firing neurons create not just thoughts but symphonies and sonnets. A synaptic impulse might follow the same electrochemical principles as a lightning bolt, yet somehow, those signals translate into the opening bars of Beethoven's Fifth or the haunting gaze of the Mona Lisa. The same quantum vibrations that jitter in the heart of a star also hum in the machinery of our minds, as if creativity itself were a force of nature. This convergence isn't coincidence, it's clue. When physicists speak of elegant theories or mathematicians describe proofs as beautiful, they're not just being poetic. They're recognizing that the universe rewards patterns that resonate, whether in the spiral of a galaxy or the rhythm of a poem. The golden ratio appears in sunflower seeds and Greek temples. Fractals echo in coastlines and jazz improvisations. Even entropy, often framed as chaos, sculpts the universe with the same ruthless creativity as a sculptor chiseling marble, destroying old forms to reveal new ones. So where does that leave us, not as passive observers, but as participants in a story much larger than ourselves? Every time an astronomer captures light from a dying star or a child splashes paint onto paper, the universe isn't just watching. It's responding. The carbon in our bones, the iron in our blood, the oxygen in our lungs, all were forged in cosmic furnaces, scattered across space, and rearranged into beings who could look back at the stars and say, "I see you." The question isn't whether the universe is art or science. It's whether we're brave enough to embrace it as both, to marvel at the equations behind a supernova while also feeling its light like a brushstroke across our souls. So tell us in the comments, when you gaze at the night sky, do you reach for a telescope or a paintbrush? Or maybe, like the cosmos itself, you refuse to choose? Don't forget to like and subscribe. We're just getting started, and the universe has so much more